So now we are ready to start this chapter 5. In chapter 5, we'll discuss about the different systems, different air conditioning system. First, we'll talk about the classification according to, say, type of condenser, or as per application, etc. General classification. Then we'll talk about the different types of air conditioners like window, split, ductable split, VRF, chill water system, chill beam, radiant cooling, district cooling system, etc. Because if you talk about the air conditioning system, you'll find n number of options. So that's the reason I classify according to the application, according to the technology, according to the type of compressor first, which can be common for different types of air conditioners. Okay, then we'll talk about which is commonly used in actual practice, the different systems. So many of you know the different types of air conditioning which is used in actual practice like window split, etc. But we have some advanced options also, and we have a central system, we have ductable split, VRF, etc. But before this, let me complete some theory. So you see, air conditioners can be classified based on various criteria, including the application, design, technology. So first we'll talk about based on application. And I think remember we discussed at in the starting classes the application of this air conditioning. It can be for residential or for commercial, for industrial, even in automobile, etc. So if you talk about application, one can use this for residential projects. Everyone aware of this. Can be used for commercial projects like malls, offices, schools, restaurants, etc. And also used for industrial side. Again, in the industrial side, you may find partly for process and partly for human comfort, because again in industry you'll find the office areas also. So depend as per the space type. Okay. Again, in that you'll find the precision type, like for a specific process like printing process, or like a server room, like crack units, etc. So this is based on application. Okay. Next, based on the design, you know, everyone aware of this window. Anyhow, we have this topic in detail to discuss. At this level, just I'm giving the idea. So according to design, we have a window AC, and this comes under the DX system. Portable air conditioners. Portable, if you don't know, I'll show you. We have a topic. At this level, just I'm giving a just basic idea. Next, split. Everyone aware of the split. And we have this topic also, but this also commonly used. Next, we have a ductable split. Ductable split means the same concept split, but the capacity is higher, and we can connect the duct and we can supply the air for multiple spaces. But don't worry, we'll discuss in detail. Just I'm giving the idea at this level. Just the name, just classification as per the technology. Later, all these types we'll discuss in detail, the advantage, disadvantage, and how it will work, with the images, videos, etc. Next, we have a package. Package in short, we don't have a separate unit. You'll find a single unit at this level. Next, central air conditioning. Under central air conditioning, you'll find the chillers. Again, in chiller, you'll find air cool, water cool, etc. We'll discuss all these types in detail. Just let me complete this classification. Next classification is based on the technology. You see, first we have conventional air conditioning. Conventional air conditioning means using the vapor compression cycle. The technology behind that conventional air conditioning is a VCR. And everyone know about the vapor compression cycle, what we discussed. The window AC work on VCR, the split, ductable split. All, even in chill water system also you'll find the vapor compression cycle inside the chiller. So there is a aspect technology. First is a conversion condition using the vapor compression cycle. Next, the heat pump. Heat pump also a vapor compression cycle, but can work in a reverse manner. Next, VRF or VRV. You see, don't get confused. VRV and VRF both are same. VRV is a patent by the Daikin. That's the reason other manufacturers, they are using this term as VRF, but the technology point of view, both are same. And this also comes under the refrigerant cycle, but in an advanced way. How exactly? We have a topic in detail to discuss. This is important. As per present market in Dubai or in India, in many locations, this is becoming popular, the VRF system. Next, chill water, very, very important. We have a detailed topic, and you see just the same thing is repeating, but this time based on technology, previous based on design. Okay, so don't get confused. Next, we have a geothermal heat pump. The concept of geothermal, we are extracting the heat from the earth. I'll give you the idea. At this level, just remember, we are using the source as earth to exchange the heat. Next, we have a radiant cooling. Radiant cooling concept is similar like chill water system, but in this we are going to run the pipe below the floor, and in that small pipes we are going to supply the chill water. Okay, so it will that this is also a special type. And now in market for big projects you'll find this at the initial stage of the project only. At the time of construction they are laying all the pipes in the floor so that one can supply the chill water or hot water as per the requirement. Just I'm giving the idea, we'll discuss in detail. Next, evaporated coolers. Today only we discuss the evaporated coolers, nothing but air coolers. Next, based on compressor type, this machines or this system can classify as per the compressor type. For example, if I talk about chiller, say air cooled chiller. Air cooled chiller can be a screw compressor type or can be a scroll compressor. So again, as per compressor also the systems can classify. So as a mechanical, I believe most of the participants already know the different types of compressors. If anyone don't know, I request to please go through once for different types of compressor. You can find on the YouTube or any RNAC book different type of compressor, because here we are not dealing with the service side, na? So I'm not talking much about this compressors, because here we are talking about the system designing, not the component designing or not for the service. So just I've given the list. So if you don't know how it will work, I request to please go through once. I'll just give you idea. Scroll compressor. You see scroll compressor, in that you'll find scroll mechanism. You need to watch some videos on this so that you'll get the clear idea. And this can be used for commercial as well as for residential systems. At the time of classification of machines, I'll give you the idea for which compressor you'll find in which system. At this level, I'm just reading the types. Next, we have a rotary compressor. In that, you'll find the rotating element which is used to compress the refrigerant. Just I'm giving the idea. Please watch the videos on YouTube if you don't have the idea about this compressor. Next, centrifugal. Remember, centrifugal is for higher capacity units, not for the small units. For small window split, you'll not find this. You'll find for large commercial air conditioning like vapor absorption system. Sorry, my mistake. Vapor, this like water cooled chiller for higher capacity up to 6000 TR. Next, screw compressor. This also for, you see, if you compare this screw scroll with the centrifugal, you can expect the maximum capacity. Next, we have a screw compressor. In that you'll find the two screws, and rotating the screw in between we are supplying the refrigerant for compression. Next, we have this variable speed compressor. Now we are using in actual practice. Even in the split system you'll find this variable speed inverter type, so that we can expect the efficiency. Next, we have a digital scroll compressor which will further help to reduce the power consumption, and this is more precise compared with the normal compressors. So these are the different types of compressors. So again, the system can be classified as per the compressor. We have a scroll compressor chillers, we have a screw compressor chillers, we have a reciprocating compressor chillers, etc. Next, based on the condenser type. This is important for interview point of view, especially for chillers. You see, if you talk about condenser type, we have air cooled and water cooled. And I think, remember, we discussed this point at the time of vapor compression cycle. If the system, or if the condenser is cooled by air, that system you can call air cooled system, na? Similarly, if you cool that condenser by using water, that system we used to call water cooled chiller. So remember the major difference between the air cooled and water cooled chiller. What is chiller we'll discuss. If you don't know, don't worry, but remember this point. Again, I'll repeat at the time of chiller also in detail. But if you talk about classification based on the condenser, we have air cooled and water cooled condenser. So air cooled chiller means the condensing unit is cooled by air, and water cooled chiller, the condensing unit is cooled by water. That is a major difference. Rest of the thing is same in both the chiller. Okay, we'll discuss in detail, but at this level, just simply remember, if the condenser is cooled by air, that system we can call air cooled system. If the condenser is cooled by water, we can call that system as a water cooled system. And this system you can find in chiller as well as in package. In package also you'll find air cooled as well as water cooled. In Gulf mostly you'll find air cooled package, but in India you'll have water cooled package also from Blue Star. Next, just I'm giving the idea. At this level you may not get these points. And when we discuss all these types in detail, you'll get the clear picture. So this was just a general classification according to the compressor, according to the technology, according to this design, according to application, etc. before dealing with the different types of system. Okay, so all the system can classify in this manner. Okay, so this is just a general classification with respect to the application or system design, etc. Now the important topic start from here: types of air conditioners. So today let me read this types first, then we'll expand these types in detail. So if we talk about the types of air conditioning which is used in actual practice, first in the list is a window, commonly used for small spaces, and most of the means I think everyone aware of this window AC. Anyhow, if you're aware, as per the syllabus we'll discuss, because this also a system commonly used in actual practice. Next we have a portable air condition. Portable means it's like an air cooler, but you'll find a flexible duct attached to that for exhaust. How, I'll show you. Next we have a split. Split means commonly used na split AC. But again in split we have a different types like high wall, cassette, freestand, and cube. This cube you'll find only with the, I think with the symphony or with one make only. You'll not find in all the makes. So, but this also a type. So I'll show you all this. Next we have a ductable split. You see example of ductable split you can find out on screen. Just the Oreo. This is a split. Again, this also a type of split. Cassette. This also a type of split. This is ductable split. And this is a window. And this is just the outdoor of VRF. We have the indoors also, and that can be connected with the multiple types. So this is a ductable split, or only if you talk about this unit, we can call this as a AHU, ceiling suspended AHU. Next package, then air coolers, then we have VRF and VRV. Technology point of view, both are same. Name is different. Next, chillers, very, very important as per the syllabus and as per design point of view also. We have a separate part for this chill water pipe sizing, that is for chillers only. Again in chiller you'll find air cooled, water cooled, as per if you talk about this vapor compression cycle. In that you'll have air cooled and water, but we have a vapor absorption chiller also, which work on the vapor absorption cycle. Next, district cooling system. District cooling system is like a big chiller away from the city and like a service provider, and they're providing a chill water through the insulated pipes, like how we are getting the municipal water from the service provider. Similarly, you'll get the chill water in the district cooling system from the service provider. In the building, we are using the chill water to cool the air by using FCU and AHU. This is just an idea. I'll show you in detail. Don't worry. Next, radiant cooling. Just have given the idea. We'll discuss in detail. Next, we have one more technology.
Can you explain this district cooling system?
Don't worry, we'll discuss in detail. This I'm giving the overview at this level. Next, we have a chill beam. So chill beam also a new concept in the market. Okay. So just what I did is just I have read this different system. Each and every system we'll discuss in detail. So let me start first with the window. So window is nothing, very simple, because you already know vapor compression cycle now. So in window AC, you'll find all the 4 components of the VCR, and this is the best example of vapor compression cycle. And you see, this is commonly used in actual practice for small spaces, single rooms. Okay, and it's a cost effective. So that's the reason, and it's like a plug and play, no separate installation. We require some installation procedure, but not like the other units. Okay, so that's the reason for small spaces or small rooms, this is commonly used. But technically, if you talk about this window, you'll find the 4 components. I'll play one small video, you'll get the clear idea. Because anyhow, you know this vapor compression cycle. So you see what are the components in window? The same components. You'll find the compressor, the condenser, expansion device, and a evaporator. And you'll find a motor with the 2 shafts. One shaft is used to rotate this axial fan, and the other side shaft is used to rotate this blower, the same for the same motor. And you'll find the partition in the window. This side is inside the space, and this side you need to place outside the building. It not mean that we can place in between the 2 rooms. No, this side must be outside. because this is the condenser side, the heat rejection is required. And this side we can place inside the room. So the same cycle, vapor compression cycle, you know what will happen in vapor compression cycle: compression, condensation, expansion, and evaporation. So this work on the same, but we have some points to discuss. How this temperature means after maintaining the required temperature, how the system controls. Because you see, continuously it will not run except the fan. The compressor will not run continuously. After maintaining the required temperature, the compressor will off. Means it will work in a cycle, on and off. I'm not talking about the fan. Fan will run continuously. When you switch off, then only the unit will off. Or else when you switch on, the fan will run continuously, but the compressor is going to be in work in a cycle as per the required temperature in the space. But how it can be done? By continuously measuring the return air temperature. But where you'll find the return in this? You see, this grill is for return and this is for supply. This is for return air and this is for supply. Means suction from this side and supply from this. And backside of this, I'll show you in the video. Backside of this, you'll find which coil? The evaporative coil or the condenser coil?
Evaporative coil.
You'll find evaporative coil, right? Before evaporative coil, you'll find sensor or a temperature bulb, which will continuously monitor the return temperature. And according to that, it will give the signal to the thermostat, and the thermostat can operate the compressor on and off. So suction from this side, and it will pass through what? Evaporative coil. And you know, when the air passes through the evaporative coil, it loses the heat and the moisture, right? Can you see these droplets? Condensation. So at the outlet of this unit, this is the supply side, you will get what? Cool and dry air, right? Okay, so continuously, so you see this section, in this section, the room air circulate, and in this section, the outside, the air suction from outside and throw on this what? Condenser coils to reject heat by using the outside air. And it is rejecting to outside only. And rejecting the heat from the condenser, you know the process. The refrigerant will change its phase from vapor to liquid. You know the process. This is, and I'm not explaining again. So the same vapor compression cycle inside this, but the high side is outside the building and the low side is inside the building. So one can install in the window or a special opening in the wall as per the requirement. It's a simple concept used in actual practice. So we'll discuss the advantage and disadvantage. Then I'll play a small video so you'll get the clear idea about this window AC. Some important points, what I explained just now, the sensor return air and how exactly, I'll show you in the video also. You see the capacity available 0.5 to 2 TR. I'm talking about in general. In most of the location, you can find this in the range of 0.5 to 2 TR. In some location, you may find 2.5, 3 TR also. Okay, so in general, for interview point of view, you can use this 0.5 to 2 TR. May vary as per location, and as per the vendor also from your location. Next, if you talk about the advantages, you see it's a compact unit, right? So we have a space saving design, and it's like a plug and play. Simple installation process required, and no brazing or no connection of copper pipes like split is not required in this. We are not disturbing any component inside, simply just installing in the window or in the opening, and we are switching on with the proper or with the required electrical supply. It will start working. So space saving, easy installation in the in the window or in the wall opening. Ideal for renters or those who don't want to make the major modification to their homes. Suppose if you decide to go for air conditioning after completing the painting and all, I'm talking about the small project. For big project, the case is different. And if in the existing flat or is this existing home, if you want to go with the split, so in case of split for running the pipe, split means you'll find two units, indoor and outdoor. To run the pipes, the wall chipping is required, taking the pipe from indoor to outdoor. So that modification work is required as per the site condition. But in case of window, only opening is required. Next, can be used as a supplementary cooling source in large spaces. Sometimes if the design is undersized, or sometime, suppose if you design a classroom for say 20 students, but for some cases, some special classes, some special seminars or workshops, suppose 30 people in that area, so we have not designed for that. So in that case, one can install this for special cases. In that case, one can use this as a additional cooling for large area instead of changing the existing system. Or in some cases, if the system is undersized, one can use this one like retrofittings. Next, if you talk about disadvantages, you see this is for small rooms only because the capacity is limited na 0.5 to 2 TR in general. So it cannot be used for the large spaces. This is for small rooms, or in many location we used to call this as a room AC. Window AC also known as a room AC, okay, or a single AC. So don't get confused. So cooling is limited to a single room or a small room, and you see may obstruct window and reduce natural light because the space is required in the window, no? So it may disturb the window. Next, appearance point of view, it look ugly because outside the building as well as inside the room, it will affect to the appearance. So interior point of view, it's not an interior choice. The interior will not, in most of the project, the interior will not accept this. They ask for the cassette, or they ask for, I'm talking about a split, under split, you'll find cassette or high wall. So for interior point of view, also we have this disadvantage. And noise, this also one major disadvantage. The compressor is very close to, means with the compressor within the unit, and the unit is in the room. Just that condenser or the compressor side is outside, but within that unit only, na. So when you use, it will create a lot of noise, like air cooler. Okay, so noise point of view, I'm not talking about all the units. We have some advanced options in there. You'll find no noise, but you see, window itself is with a limited capacity. So you in many manufacturer, you'll not find the on this high class type in that, because this is not a for high class. You can expect in cassette. Sorry, you can expect in the split system. So normally you'll find a lot of noise when you operate this one, and noise means, this is one of the parameter for air conditioning, maintaining the noise level less than 35 dB. So it will not satisfy the all parameter of air conditioning as per the definition of air conditioning. So you can consider this as one of the major disadvantage in this. Okay, apart from this, in window, even in split, you cannot expect the standard fresh air. In window, you'll find some option for fresh air in some models, not in all the models, but still that option is not as per standard requirement for to satisfy the fresh air requirement. Okay, so ventilation is not as per standard. This is also one major disadvantage of this window. So let me quickly one small video clip. You'll get the idea.
While air conditioners can differ from model to model,
Yeah, please have a look.
air conditioners can differ from model to model. They all operate on similar principles. In this video, we will address how an air conditioner operates, as well as potential problems you may encounter. When you switch the air conditioner on, the thermostat control sends 120 volts of alternating current to the compressor and the fan motor. The compressor acts as a pump, compressing refrigerant in gas form into the condenser coils located near the back of the unit, where the gas is condensed into a hot liquid. The condenser coils dissipate the heat as the liquid travels through them. Once the refrigerant has passed through the condenser coils and the capillary tube, it travels to the evaporator coils, located near the front of the unit. As the refrigerant liquid enters these coils, it expands into a gas, which makes the coils cold. The gas flows through the coils to a suction line attached to the compressor. The compressor converts the gas back into a liquid, and the cooling cycle continues. At the same time, the fan motor rotates a blower wheel.
You can see here only one motor with the two shaft. One shaft is connected to the blower, which is inside the room. Other shaft is connected to the axial fan, which is used to cool the condenser with the forced convection.
which draws in air to be cooled by the evaporator coils before recirculating it back into the room. The same motor also operates the condenser fan blade, which blows outside air through the condenser coils to cool them. The air temperature is regulated by the thermostat control. Depending on the model, the control may be a thermostat switch and sensing bulb assembly, or an electronic control board that works with a sensor. The sensing bulb or electronic sensor.
You see, this is important. The sensing bulb you will find when you remove the front panel, means before this evaporator. This is related to evaporator side. So it means, you see, when the suction takes place, it will pass, it will pass through this, and you see this strips are fins, and in that you'll find the coil. In that you'll find the coil. So this is a cooling coil. So the suction from the room passes through this, and continuously this sensing bulb will monitor the return air temperature. Okay. And monitoring the return air temperature can control the compressor. But how? For example, suppose assume that you switch on the window AC and you set the temperature, say 23 degrees centigrade. In the window, with the window, you'll find the remote also, or else the manual, you can set that temperature, the required temperature, 23 degrees centigrade. And assume that the present room temperature, say 30 degrees centigrade. So what will happen when you switch on this unit and setting this 23 degrees centigrade, you'll get the cool air. And the room temperature start decreasing now. Okay. So 30 to say 28, say 25. So after some time, you can expect this room temperature, say 24, and further say 23, what we set. Okay, we have plus or minus say 1 degree centigrade or 0.5 degree centigrade, throttling range. So when 23 is attained in the room, so what will happen in the return air also, you'll get the same temperature, na? And you see, continuously this sensor will monitor the return air temperature. When the return air temperature same as what you set, what will happen? This bulb is continuously monitoring the temperature, giving the signal to the thermostat. The thermostat will cut off this or trip the compressor. But the fan will not stop. The fan will run continuously. And the continuous process, after some time, the compressor is off now, so only air is supplied, not the cool air. After some time, the temperature may increase. Suppose 23 to say 25, or say 24 or 25, and this is continuously monitoring the temperature now. So when the temperature increases, again this bulb continuously providing the signal to the thermostat. When the temperature increases, again the compressor will on and supplying the refrigerant to supply the cool air. And remember, this concept is not only for window, even for split or ductable split, or even for chill water system, FC or AHU, you'll find the same concept. So I request you please make a note of this. Please make a note. Window, split, ductable split. At this level, I'm not adding chiller, because in chiller we have air side control and water side control. But again, air side control, the same concept. Okay, so window split, ductile split, and if you want, you can write chiller air side controls by means of return air temperature. By means of return air temperature. And this can be asked in interview. Or in short, I can say return air temperature is responsible to control the compressor on and off for window split or ductable split, etc. This is an important point. Next.
Is clipped to the front of the evaporator coils to monitor the temperature of the air entering the coils. Once the room has sufficiently cooled, the thermostat control shuts off the voltage to the compressor. Some models which use a vent can operate the fan motor.
You see, this is a fresher option in some models, not in all the models, in window.
Only to draw in cool air at night. However, when the appliance is actively cooling the air, the vent must be closed for the system to work properly. Be aware that it's normal for water to collect in the
You know about this. From where we are getting this water? This water because of condenser or evaporator?
Evaporator.
Right, evaporator is the correct answer. And now the source of this water
That moisture content.
means from the room air, right?
Yes.
bottom of the air conditioner when the appliance is running. A slinger ring on the condenser fan blade picks up this water and sprays it onto the condenser coils to help the coils dissipate the heat.
And you see this spraying the water on the condenser coil, you'll not find in all the models. In some models you'll find. This will help to increase the efficiency. The same condensed water, because it is going to be available in the same drain tray at the bottom now. So it can be utilized to cool the condenser to increase the efficiency, but not in all the models.
To prevent the water from dripping into the room, the appliance should be tilted.
This is also important point. The drain water must be through outside, no? Or else you will get the leakages inside the room. So at the time of installation, we are maintaining slight inclination, like say 5-degree inclination towards the drain point. Okay, and we'll take the drain pipe and connect to the proper drain location. At the time of installation, you need to maintain a slight inclination towards the drain point. This is also important, or else you'll get the leakage of water, condensed water in the room. Or else, if the water is available in that room site, it may increase the bad smell or the fungus and other issues.
It back slightly when installed.
So hope you got the idea about the window. This is a very small unit and it's like a plug and play. There is no installation procedure or list something. Simply you need to install. Just you need to take care for the inclination and at the time of installation, after installation, you must check for any leakages. And if any leakages means that will increase, that will decrease the efficiency. Okay, so check for the leakages, and when you use this one, generally we are closing the door and window, because this will increase the load if you not close the door and window. Not only for this, even for other AC also. Okay, so this is about the window, the first type in the list. Let me continue with the split. Okay, split air conditioner. In that split, you'll find different types. So we'll talk about split. In that, we'll also discuss the different types of split. And next, we have ductable split, package, etc. Okay, so let me continue with the split air conditioning system. So the name will give you some idea. Okay, so see, if you compare window with the split, in a split air conditioning system, the four components, what we discuss, the four major components, what we discuss in window is going to divide into two different units in a split air conditioning system. So we'll discuss all in detail. So the first point is why the need of splitting that components into two units. Because you see, we are getting the cooling from the window. So the first point is why the need of splitting that four components into two units. The major reason why the need of split. But before this, let me share the screen. Here you can find an image, just an overview initially. Then we'll discuss in detail. In this image, you can find out this is indoor unit and this is CU, condensing unit, or outdoor unit. Okay. So in outdoor unit, you'll find compressor and condenser and even expansion device also. And indoor unit, you'll find evaporator. Okay, I'll give you the detailed information about the components at this level. Just I'm discussing in general to get the idea why the need of splitting this, why the need of splitting these components into two units. Okay, so this is a indoor unit and this is a outdoor unit. And in general, this indoor unit we used to call FCU, nothing but fan coil unit. And this fan coil unit is common for split system, for VRF system, even for chill water system. Okay, so we have a separate topic of FCU after completing this package. Before dealing with the chill water system, we'll discuss the difference between FCU and AHU. Okay, so remember this unit we can call as FCU, fan coil unit, or in general indoor unit. So the major reason why the need of splitting this components into two units is to reduce the noise. Okay, I think remember in the last session we discussed about the window, and in window, in under the disadvantage of window, we discuss noisy type of machine, right? Because the compressor is close to the conditioned space now. So whenever you use that window AC, you'll get the noise from the compressor. Okay, and noise also one parameter for maintaining the air conditioning now. So if you split this components into two units, one can reduce the noise, because in outdoor unit you'll find the compressor, okay, and the noise and the vibration from the compressor now, so that we are going to separate in outdoor unit, which we are placing outside the space, outside the building. So one can reduce the noise. This is the major reason. Apart from this, we have some advantages and some disadvantage also for this. But the major advantage of split is one can reduce the noise compared with the window. Okay.
For window, we can put the like the partition one, like in between there is a room, so we can put that window. I mean window AC in that, but in between room. But this split can be put, right? This is an advantage.
No, you see, we have a list of advantages. At this level, what I discuss is only the major point. Okay, we have a lot of things to discuss. Don't do the conclusion at this level. So here you see split AC, also known as split system or the split AC in actual practice. And this also comes under unitary system. Window, split, both comes under unitary type. Why I'm talking about this unitary? Because you see, if you talk about the ductable package, etc., that comes under central air conditioning system. In that sense, these two units we can consider as a unitary. Unitary means the unit wise as per the zone requirement. And here I request to make a note of this point. Please make a note. Zone refers to thermostat. Zone refers to thermostat. I will discuss in detail. I'll give you the quick idea for the zone. For example, because repeatedly I'll use this term zone. That's the reason you must aware of this. For example, consider a floor with say multiple rooms. For example, total say 6 rooms. 1, 2, 3, 4, 5, 6. Okay. So in general, we used to call room. Technically, for mechanical or electrical, we used to call spaces. Okay, so these are all total 6 spaces. And in each space, I'm going to use a split AC. Suppose split AC 1, 2, 3, like so on, 4, 5, 6. And for this, we have a separate outdoor for each unit. So you see, in this case, number of space is 6. And in each space, I'm using a separate individual split system. So zone also 6. Because one space, one unit means one control, means one thermostat on and off individually can operate all these rooms. In case if I use a central AC and if I use a package or a AHU, and if I connect all this with the one unit, I'll show you how exactly. Just this level, focus on the zone. So just by some means, if I cover all this space with a one unit, in that case, number of space is going to be 6, but zone is going to be 1. So remember, zone refers to thermostat, how you're going to control the spaces. If all the space is going to control with one unit, means one thermostat. So number of spaces 6, but zone is going to 1 in this case. It can be 10 space, 10, 20 space, whatever as per the space, as per the project requirement. So I think got the idea of what is a zone and space online.
Yes.
We'll discuss with more detail. Don't worry at this level. Just so now you see what are the different types of split. So the major point, the split consists of what? An indoor and an outdoor compared with the window. And remember, if you talk about the 4 major components, what we discuss in vapor compression cycle, the same we use in window. Na? In split also, you'll find the same components. I'm talking about the major components. So if you talk about the 4 major components, compressor, condenser, and expansion you'll find in outdoor, and in the indoor you'll find evaporator. If you talk about the main components in the latest models, if you talk about old models, expansion you'll find in the indoor unit. Okay, why now in market they're using the expansion in the outdoor unit? There is a reason we'll discuss. Let me just complete this theory part first. So now if you talk about the different types in split, you will find n number of types, but most commonly in actual practice you can find high wall. You see on screen, this is high wall, and this high wall cassette or this tower is based on the FCU. You see, as a cell in general, this we can call as FCU, fan coil unit, and coil refers to the cooling coil. So this high wall cassette and the floor stand or tower is based on the FCU. The outdoor is going to be same for all the three types. Means the concept is same, but the type of indoor is going to be different. Nothing but FCU according to the interior requirement or the site condition or the clearance or interior requirement. So if you know the mechanism of high wall, the same principle is for cassette as well as for tower. I'll give you all this detail, don't worry. So there are three types most commonly in actual practice. High wall you can find on screen. Next is a cassette. Let me just show you the preview. This is a cassette. I'll show you detail with this with small video clip also. This is, and you see this is again connected to the outdoor, and this is ceiling suspended. So high wall is going to install on the wall above 6 feet as per standard, and this ceiling mounted is a cassette, and this tower or floor mounted, quickly let me show you the preview, we'll discuss in detail. Tower is like a vertical unit you can find on the screen. You see this is called tower or a floor stand. Some used to call freestand also, but I'll not recommend to use the term freestand, because once you install you cannot move this like air cooler, because again this also connect to the outdoor unit. Apart from this, you may find the ceiling suspended type, or else you'll find a floor mounted FCU, or you'll find one-way cassette, two-way cassette. Different models are available in market, but most commonly in a split you'll find high wall, cassette, and the freestand. So first let me complete this high wall. So you can find the first type in this is a high wall. And why we are calling high wall? Because we are going to install on the wall with at least above 6 feet height from FFL. FFL, if you don't know, please make a note. It's a finished floor level. In short, we used to call FFL. We'll discuss about this terminology at the time of building survey. So final finished level of floor is called FFL. From FFL, not less than 6 feet, above 6 feet only, because up to 6 feet we are considering as a occupied zone. What is occupied zone? You'll find the time of topic called air distribution. So next, what are the components in indoor? You see in this high wall, this is called FCU. So first we'll talk about the components inside this, then the components of this outdoor unit. Okay, so I've given the list here. Let me read this first. Everyone aware of this evaporative coil? We'll discuss that at the time of evaporative cycle. I'll show you the fins and the coil in a small video clip, which is common for condenser as well as for evaporator. So in the indoor unit, you'll find evaporative coil. You'll find the blower, cross flow blower. Blower is a type of fan. I'll show you in the video. Give me a minute. You'll find the air filter to clean the air at the time of suction. You'll find the blower motor, which is used to run that blower, means the fan. You'll find the control panel, which is used to operate the remote control and other function like the current and all, the power. Next, drain tray at the bottom, which is used to collect the condensed water. On evaporative coil, you'll find the condensation of water. No? So at the bottom, you'll find a passage which is used to collect the water. We used to call drain tray. Next, supply and return outlet. Don't worry, just let me read this. I'll show you all this in the picture as well as in the video. Next, air deflection motor. A motor inside a small motor, which is used to operate the swing blade at the outlet. And you'll find the swinging blade, which is connected to a small motor. remote control, everyone know this, and suction and liquid line outlet, okay, which will connect to the with the copper pipe, and that copper pipe we are going to connect to the outdoor. And why we are calling suction liquid line, that also we'll discuss. So these are the components for indoor in the high wall. Similar components you'll find in other units also. The shape and the position may vary, but the component is going to be same. Next, if you talk about outdoor unit, as we discussed at the beginning of this session, compressor. You'll find the compressor, no doubt. Condenser, which is used to reject the heat. So that must be outside in the outdoor unit only. No? Expansion device. In present market split system, you'll find this expansion device in outdoor only. In some models or in older models, you'll find this in indoor. Now the point is, if you place this expansion valve in the indoor, it's after expansion, the pressure drop, na? After expansion only, we have this low side. Then why we are using the expansion device in outdoor? You see, the concept of split is for what? To reduce the noise na, compared with the window. So if you use this expansion device in indoor unit, what will happen? You'll find the hissing sound, because at the time of expansion, the refrigerant is going to be supplied with a very narrow cross section to the wide cross section area. Na? So you'll find the hissing sound. So again, that will, to reduce that hissing sound in present market, you'll find this expansion device also in the outdoor unit. Okay, in old models, you may find in the indoor also, or in some models, some makes, they are still adding in the indoor. But if you talk about high class like Daikin, in Daikin, you'll find the high class models, or in many makes, standard makes, you'll find in the outdoor only. Next, a separate fan motor, which is used to run an axial fan, which is used to cool the condenser. It means for condenser fan. Next, electrical components, again for power supply and providing the power to all these components. Again, liquid and suction line, which is common in both the units because interconnectivity of the pipes. You see, drain outlet is going to be a part of indoor. Next, let me confirm all these components. But before this, I'm going to play a small video clip. You'll get the idea about this coils. It can be a cooling coil or it can be a condenser. In both, you'll find the copper tubes and the fins. Okay, so I'm going to play the video. First, let me confirm these coils. Then in other video, I'll confirm all the other components.
One essential component in air conditioners must be the heat exchanger in its dual application as a
Can you see this copper tubes? And you see this copper tubes with a bunch of fins. You see this thin plates is called fins. And as a mechanical, you know the purpose of fins, right? This fins is used to increase the rate of heat transfer by increasing this surface, right?
Surface area.
So this is common for any heat exchanger. Okay, or this condenser or evaporator in general is a heat exchanger only. No? This tubes you'll find with the copper and fins with the aluminum. This is a default configuration in actual practice. In some models, you will find copper tubes, copper fins for the models, which is going to use in high humid areas. Or apart from this, in market, you'll find copper tube, blue fins, or some additional coated fins, which is used to increase the life of this. Because this, if you talk about this heat exchanger, the same heat exchanger we can use as a condenser in outdoor unit. So if the outdoor unit is placed in the humid areas, if it is aluminum, the life is going to be less. So in that case, even the fins also you'll find is made up of copper or with the additional coating. That depends as per the model. But if for interview point of view, the default configuration is copper tube aluminum fins.
Denser as well as evaporator. Changing from smooth bore copper tubes to internally enhanced inner groove tubes enable to move towards higher efficiency heat exchangers. The process of coil making includes the use of...
You see this process called drawing process. And remember, the copper tube is welded and seamless. The copper tube is a seamless pipe, not welded pipe.
Hairpin tube cutting and bending machines, which draws the tubes from the copper reels, cuts them to the required length, and bends them 180 degrees. Alongside is the fin pressing, where the punching of holes, corrugating of the surface, and cutting to the required dimension takes place. Fins are then collected, end plates attached, and hairpin tubes inserted, thus forming the heat.
Here you see, you can consider this heat exchanger as a 3-coil heat exchanger. You see, 1 row, second and third. So it's a 3-coil or 3-row heat exchanger. You may find 1 row, 2 row, 3 row, 4 row, depend as per the capacity or as per the model.
Exchanger coils. Coils are then moved to the mechanical tube expander, where mandrels are inserted to each tube, which mechanically bond the hairpin tube to the aluminium fins. The return bend machine fabricates copper return bends, or elbows, from copper reels, and then the brazing rings are inserted mechanically. One final step completes the circuiting loop for the successful flowing of refrigerant through the heat exchanger coils. Loaded onto the brazing conveyor,
you see here we'll apply heat, and this process is called brazing. So to complete the circuit,
coils are fitted with elbows and brazing rings. After pressurization, coils move over to the automatic brazing furnace for leak-free connections. Connecting the various air conditioning components requires accurately bent copper tubes. Utilizing CNC three-dimensional copper tube bending machines that conform to the hundreds of various coil connections permits error and defect-free production of volume and quality.
yeah, so you see the heat exchanger, what you observe in the video, is common for not only for split, even for ductile split or for package or even for VRF, you'll find this heat exchanger, and the procedure is going to be same. Next, we'll talk about this line diagram and some more details. But before this, I have one more video clip. In that, you'll find the information for this split system. So again, I'm going to play this.
All previous processes feed into the mini split assembly line, where indoor and outdoor units
This is a condenser fan motor of outdoor unit.
are assembled and tested before packing. Starting with the base pan,
Here is a compressor, and you can find this isolators, this rubber to reduce the vibration.
condenser fan with support, compressor, condenser coil, and interconnecting copper
You see, this is a condenser coil.
tubes and coil guards are added.
Here, one important point to discuss. These are two valves. If you closely observe this, this is called liquid line, and this is suction line or the gas line. Most commonly in actual practice, we used to call suction line. Now, if you closely observe, the suction line dia is bigger than the liquid line. So remember, this is important. May I ask an interview? Why the suction line is bigger than the liquid line? So in order to understand, first of all, the direction of flow is required. Okay. So you see, this liquid line flow direction of refrigerant is outdoor to indoor, because in the outdoor you'll find compressor, condenser, and this expansion, right? So the refrigerant, it is going to condense in condenser, no? It will change its form from vapor to liquid in the condenser, and the same liquid will pass through expansion device and will come out in the liquid form only from the outdoor unit. And from the outdoor to indoor, the refrigerant is in liquid state, right? And in the indoor, what will happen? The change of phase, this evaporation process, and the refrigerant will change from liquid to vapor. So out indoor to outdoor, you'll find the suction line. The direction of the suction line is indoor to outdoor, means towards from indoor towards outdoor. So the indoor to outdoor, the refrigerant state is in what? Vapor. So remember, vapor means the volume increases, and so remember, when the refrigerant convert from liquid to vapor, the volume increases, no? And increase in volume means required additional space. And when the refrigerant flowing in liquid required less space. Okay, apart from this, there is a density difference also na, in liquid and vapor, right? So this is the main point and important for interview point of view. So remember, outdoor to indoor, liquid line, indoor to outdoor, suction line. And the suction line that is bigger than the liquid line. We'll talk about the pressure rating also. We have a table as per the different refrigerant, but let me complete this video first.
After brazing, units are pressurized for air leaks and dehydrated.
And the refrigerant charging in the compressor.
Final assembly, including electrical control box and wiring, permits one last functional test prior to packaging and stocking in the finished goods warehouse.
Here on the nameplate, you can find some additional information. You can read FLA, RLA. Remember, LRA. You'll find one more, RLA. So you see, FLA is a full load ampere, LRA is a lock rotor ampere, and RLA is a rated load ampere. So what is this amp? And you know, ampere refers to the current, no? The unit of current. So remember this term. We'll discuss after this video. This is important for interview point of view also. Actually, this terms is related to the service side, but this is very common. May ask in interview even for the designing or for installation engineer also.
The indoor unit assembly starts with a back panel.
In FCU, this is a high wall FCU, nothing but indoor unit. You'll find the blower, and this is a cross flow blower. The type of the blower is a cross flow blower.
Followed by the blower fan motor.
This blower is connected to the shaft of this motor. So you'll find a separate fan motor in indoor and separate in outdoor. Outdoor for condenser fan and indoor for this blower.
Sir, one question.
Yes.
When the blower blow the air to the rooms, at the same time it sucks the air from the room also, right?
Yes. Don't worry, I'll explain this.
Simultaneous process is happening.
You see, supply of air with any fan with the suction only, not only in this indoor, even in outdoor, in the axial fan, throwing that air with the suction from outside. So if the air is supplying means without suction, it cannot be done, right?
And at the same time, it's not possible to suck only hot air. It's mixed air like cool and
Hot air from where?
room inside room.
Don't worry, at this level, don't do the conclusion. Let me complete this video. I'll show you the procedure, how exactly the airflow through this evaporator coil.
Evaporator coil, dehydration, electrical control box,
You see, this coil is a evaporator coil in the indoor.
wiring harness, functional testing, and front panel fixing. It then moves to packaging.
Now you'll get the answer to your question. This is the outlet. And the suction, in some model, the suction from the front or suction from the top. Mostly in many models, you'll find the suction from the top. And when the blower operates, the blower is backside of what? Evaporator coil. No? So whenever you switch on this unit, when the blower start, it will start suction from the room. So this we can call as a return. Return means at this level, I'm using the term return because this we can call as a supply. Na? This is suction from the room with this above grill, or it can be from this part or from above as per the model. So when the suction take place, first it will pass through the cooling coil and loses the heat and the moisture, and the cool and dry air will come out from this outlet. At this outlet, at this level, the outlet is closed. When you switch on, this outlet will open and it will swing. You know this, right? It will swing. It will swing up and down. And for that also, you'll find a separate small motor. So what will happen? In between, you'll find the cooling coil. So it loses the heat and moisture. You'll get the cool and dry air at the outlet.
That is paired to the condensing units in the finished goods warehouse.
Now we'll discuss some more points related to this on screen. Here you see, this is the outdoor unit connected with the copper pipe. You'll find the two valves here because two pipe will connect. And you see this two pipe separate insulation, and it's going to run with the 3-inch conduit pipe as per standard. And you'll find the detailed drawing below for this site. And you see this complete pipe is connected to the indoor. And in the indoor, in this model, the suction from this front side. Some models you'll find the suction from the top. And this is a discharge outlet. And at the bottom, you'll find the drain tray. You see, you'll find the drain tray here. And the condense what is going to collect it at the bottom of this drain tray. In all the models, you'll find this. And to which will connect a drain pipe. You see, this is condensate drain pipe run inside the wall. Normally, it should be concealed. But normally, if the installation is not standard, it will be visible also. But as per standard, this pipe and this pipe should be concealed. We can take this pipe out through the wall, but in this case, you see, we are taking the pipe through this wall, and this is a pipe chase. And through the pipe chase, the pipe is going up through this slab connecting to this out unit. Okay, and this through the slab means here the pipe sleeve. Pipe sleeve is required, and the drain pipe. 1 minute. The drain pipe, you see here, this is the drain pipe which is used to collect the water, and we are going to connect to the nearest flow drain or to the plumbing drain point. It can be near the point. Suppose if it is a kitchen or if it is a toilet, we'll connect to that. But before connecting to this, we required one more important, that is called U-trap. I'll give you the idea. For example, this is an indoor unit and this is a drain pipe. So what we'll do, we'll take a U-trap like this. And this is very, very important. Yes, online?
Yes, sir. Do we provide the insulation on the condensate drain pipe?
Yes. For split, generally, we are not providing, but for ductable split is required. Because you see, this is directly, we are taking out, na? But in ductable split, it is required. But split you can ignore because this pipe is for single unit and it is going directly out of the space. But you see this U-trap, this is called U-trap. U-trap means it's simple. Normally in plumbing, you'll find the P-trap, na?
So I'm not getting this. I'm not getting this point that this high wall we don't require insulation and other type for drain pipe.
You see, after completing this ductable split, you can understand this. But for high wall, is not required. For high wall, is not required for insulation for the drain pipe because this we are taking directly out, na? So why the need of the insulation? Because this is
directly out. That means we are putting hole in the wall and giving outside.
Yes.
Saying.
Or through this wall, conceal, taking the out. So we don't require the insulation for this. But for this copper pipe, insulation is must. Now, so you see, this is FCO, the same one. And this drain pipe, I'm adding the details. This drain pipe here, before connecting to the flow drain, you must add the U-trap. This is called U-trap. And why the need of this U-trap? And remember, this U-trap is not only for this FCO. This concept you'll find even for AHU. The AHU can be a chill water system, with AHU can be ductable split, or the AHU can be a VRF system, which is this AHU and FCU is common for all the systems. So at this level, if you're not getting this term, don't worry. We have a topic to discuss about this efferent system. So I'm just giving the importance of U-trap because U-trap is not only for FCU, it's also for the AHUs, which we'll discuss in the next sessions. So you see the purpose of U-trap, it will create a water seal. Like in drainage, WC, you'll find the P-trap, no? And in that P-trap always you'll find the water. So this U-trap also used to create a water seal so that this is connected to the indoor, no? And this is connected to the nearest flow drain. And the flow drain can be a toilet flow drain or a kitchen flow drain. So if you connect to this, what will happen? If you directly connect this drain pipe to the indoor unit without the U-trap, what will happen? Inside this FCU, you will find the blower. No? Blower means the suction pressure. So what will happen? It may suck the bad smell from the drain, from the flow drain. Also, if you not use this U-trap, the insects may travel and may enter inside this FCU. And if you use this U-trap, what will happen? Always the water is going to present in this because this will create a water seal. Na? Whenever the water level increases, it will push and the water will go out. And some water always in this trap because of with the gravity. Okay. And also we require a slope, at least 1% slope for this pipe. We cannot take this pipe like up. Always you must take down with a proper slope. And you see this horizontal pipe must have at least 1% slope. And if you not maintain this slope, what will happen? If the drain water is not draining out properly, it's going to be collected at the bottom of this unit, that is a drain tray. So what will happen after some time, the dripping of water in the room or the leakages will start. So this is a small point but very important. So be careful. You must take care for this U-trap and maintain this slope for this drain pipe. Okay, and this point is common for all FCUs and AHU except cassette. In cassette you'll find the inbuilt motor that you'll find in the next. Got the idea online about the U-trap? In short,
Yes.
remember, U-trap is used to create water seal between the two side of this pipe. Suppose this is point 1, this is point 2. So in between, you'll get the water seal.